time. Can we bring back time? Well, here in Cape Town is somebody who brought back time.
Mr. Clock, he's a horologist, right?
You can say that.
Yeah. All the old classic clocks here, the vintage clocks in Cape Town, are restored and back up and working again. Very likely this is the man who got it going.
You fixed the clock. Yeah, but what was the problem with this clock?
They did quite a big restoration a couple of years ago, but there was a problem with the strike and the chime system. Okay. So we're going up to the base of the tower, and that is where the musical drum is located and the carillon system. And that plays, if I'm correct, on 41 bells, up from very small bell up to huge brass bells. And you got a couple of foot pedals and stuff, and then you work it by hand.
It's like a big organ, actually, eh?
That's exactly. This is just one that they use for practice. It's a lot smaller, so it actually knocks on these little tubes here.
Oh, I see. And this is like a jewelry box thing that just plays automatically a tune, right?
This is basically like what you get in a jewelry box, a
Yeah.
small little musical drum. This is just on a much bigger scale, and it plays two different tunes. So this lever you can push over, and it selects on which tune you want to play. And it's basically just the electric motor, the drum, and that plays on the bells.
And would that be a certain time or?
No, this is totally manually operated. This is whenever they do, I'm not quite sure when they use it, but you basically just switch it on and it can run anytime. It's not connected to the clock in any way, but it runs on the same bells.
So who plays the time? 12 o'clock, whatever.
It's automatically done by the clock.
This is just rewind, back to the start. And so we have in the building, we've got what?
We've got three different systems here. We've got the clock that gives time that you can see from the parade up on the 4 dials. Then if you look here, we've got the musical drum.
Yes.
And behind us, we've got the carillon. Plus you've got the practice carillon. Now the practice carillon is not connected to any bells whatsoever. It's got its own tubes, all that. That's more for practicing.
Yeah.
Then you've got the carillon system, which is connected to 41 bells up in the tower, which you can play. Notes and all that, and then you've got a totally separate system, which is a musical drum, pretty much the same as you get in a little jewelry box.
How's it? Sorry, somebody just arrived. Who's this?
Marius.
Marius. Okay, so what's Marius do?
Marius was the project manager on the clock for us.
So he can tell us what kind of info?
He knows a little bit more than I do of the history of the building and where everything comes from and the date timelines and stuff like that.
So with the installation of the clock back in 1905, there was a project commissioned to actually install some bells to actually activate the chime mechanism. But at the time they decided that they want to replicate the Westminster chime, so they commissioned 5 bells to be installed initially to replicate the Westminster chimes. And then that was used to chime, for the clock to chime, and then over time the mayoress at the time in 1925 actually commissioned the carillon itself, and then she added some bells to basically create the First War Memorial.
Part of the
The main frames are a timber structure where the bells are actually mounted on, and you can still see some of the mounting points of the old crane that was here when they actually erected the structure, and then fixed the bells too as well.
We've come now and right near the top of this. This feels like the dome just before the clock. I think we're getting now to the meat of it, isn't it?
Correct, yeah. The clock is just a level above, and this is actually where you can see the shafts. So the weight shafts basically that run the clock, there's 3 of them, one for each train. They run down the shaft all the way down to the base of the tower. So,
okay, this is a big shaft that goes right to the top.
Yes.
Oh, and there's the weights.
There's 2 weights there that run 2 different trains.
So we're talking about gravity then. So gravity, this weight is coming down.
Correct.
And how long does it take for this to come down?
It's about 4 days.
4 days?
Until it has to be winded again, yeah.
And then you pull it back up and then,
manually wound every 4 days.
Okay. But then what about happens to the time in between?
No, the time keeps running. As long as the weight is suspended, the clock will run.
Oh, even if you're winding it up, it still
the
runs.
mechanism has what they call a power retaining system. So even if you wind the clock, it keeps time. So you won't lose time as it is wound.
Okay, Brendan, this is now the base of where the clock is, but before we go and have a look at the clock and the pendulum, got a really nice 360-degree view of the city here and Table Mountain, but it's under a blanket today.
Okay.
So yeah, here we got the 4 dials. Amazing to think it's 4-piece dials, all casted, and then it's what you call opalescent glass, which is a hell of expensive glass. But it's what they've been using for centuries, so we try and stick to it.
Opalescent.
Opalescent glass, yeah.
Just meaning that it's. Hey, look at this. Now we're walking around the top of the clock, and here is Cape Town, guys.
Cape Town signal hill from this side,
From a
then you got the
no one would
parade from the
ever.
front.
That's why us YouTubers are lucky.
Get on here.
And look at
because-
that.
Get up here because you also got a very nice view of the castle from up here,
Oh, is it?
which people don't really.
Ah, look at that. There's the castle, guys. Well, some would term that a fort, but. So, tell me, did you have to do anything with regards repairing anything?
Dial
of
side
the-
at this stage is not on the list, but there will probably be maintenance on it in the next couple of years. It is quite a tricky one because you need scaffolding everything, and to take those 4-piece dials apart is quite fragile and there's quite a lot of risk involved, but I think they can do with a proper good sandblasting, new coat of paint and the glass repaired. There's 1 or 2 glasses
I'm
repaired.
sure here by Cape Town there's a lot of rust and stuff here. Hey?
It is, and you'll see which side the wind comes from. Oh, this one's more damaged than the one on the other side and the one at the back. So
Okay.
that's where our wind comes from the
Okay.
most. So
Really, this is it. We're inside
this is
the
where
clock.
the heartbeat lies.
But I mean, look at all this. In the back of a clock, it's almost like what movies are made of things like places like this, eh? Oh, and this is it. This is the brains. This is obviously what you were involved in fixing.
This is the part. All of this standing here is the part we were involved on, right up to the gearboxes here by the dials.
Yes.
But we'll get to that later on because that's also a very interesting subject. You've only got one single tube. Nothing inside, a solid tube going up, and that single tube is feeding 4 dials, and it's telling it hours and minutes. So it's also.
And you've got this thing accurate. Yeah. How accurate?
We've got it down to about 20 seconds a week at the moment. We started off with a minute. We knew it was going to run faster and faster and faster because we've remade quite a lot of the bearings and the bushings.
Yeah.
So as they're starting to bed in now, it will start running. But every week I come in and I just set it slower, slower, slower. So it's good when you start and it runs faster and faster. If it runs slower and slower, you know you messed up somewhere.
Okay. The gravity was pulling that, and then what
Pulling
happened?
down on this cables that's on this first drum here.
Yeah.
And this drum, as you can see there, is connected with a big brass gear that already goes up to the dials and tells time. But then you've got another gear here and a smaller wheel and your escapement, and that releases power at a very constant rate. And that's how it tells you accurate time.
And that's what's moving the pendulum as well.
That's what moving the pendulum as well. From that side just now we'll get a much better view of it. And this is quite a complicated escapement. It's what we'll call a 3-legged double gravity escapement, and they normally use it on bigger clocks with big dials like this.
Yeah.
The one we're going to show you later on has got a very smaller dial, so you don't need such a big complicated escapement. But it's got very wind and stuff like that has got very little influence to the hands. Those hands are massive and they've got huge weights on the ends. So when you basically stick your finger in that one hand and you spin it, it will just slowly get to a nice and even balance. They're perfectly balanced.
Incredible, hey? I find it fascinating that if you look at a watch, it's got all these little parts and everything inside, but yet when it's all sort of expanded like this, it looks so simple actually,
Listen
doesn't it?
here, it's basically got the same movement as what you've got here. Here you've got a different escapement again. You've got a balance. Here you've got a pendulum. But the gearing and what it's supposed to do is exactly the same from what you wear on your wrist up to here. This has got the added chime and the strike now, but the rest is, it's just micro-engineered to your arm, but it's exactly the same principles.
Okay, so what did you have to fix on the clock?
We took this whole clock apart totally except for the base, because as you can imagine, you saw the stairs we came up now. we had to carry everything down. So the base stayed here. Luckily, the drum bearings and all that detaches. So we could take all of this out. We did new bearings inside the drum bushings, and we did it in such a way that we kept the original bearing. So this is the original bearing, we just put new liners on the inside. There was also some repairs on the time train. There was a bearing done there. There was a bearing done on that side. And quite a bit of work on the chime train. The chime train was totally out of sync. You've got a count wheel here, which makes it chime every quarter. So quarter past, it plays 4 notes on the musical drum here.
Ah, there we go.
Half past, it plays 8 notes on the musical drum. Quarter to, it plays 12 notes, and on the full hour, 16 notes, and then this lever activates the strike side. And that's the big bell we saw down there. It strikes.
Oh, there's this cable.
There's the cable.
There's the cable. And yes, this must be for the smaller ones.
That's for the smaller ones, the 5 smaller bells. And also a nice added thing that we did here, because the Philharmonic Orchestra plays here every Thursday night, there's a silencing system, which we didn't mess around with the original system at all. It's just pneumatic motors. And at the base of the tower, if you switch it, it lifts up all those arms away from the drum. So it will still strike as normal,
yes,
but the fingers won't pick up, so they can silence it.
And it won't make any noise.
Won't make any noise.
Fantastic. I was just thinking now when I'm looking at all of this, and I'm thinking, you know, we have got computers and things to work out this weight to that size, exact size of the gear, and they did it how? I mean,
this was done years ago. I mean, this is 150 years plus. If you look at some of the very oldest ones, I think the oldest one has been running since 1375 in Prague. Those were mainly made more by blacksmiths, but just, I mean, there's a pretty simple formula. Well, I say simple when you're into mathematics.
Yeah.
But what fascinates me even more, not just that they had the knowledge, they had no electricity, they had no running water, they didn't have access to any of the tools we have today. It was basically made by hand, and I think that's the fascinating part about it.
Yeah. Oh, yeah. Of course, the lathe. I mean, we can lathe a thing like that. They didn't have a lathe to make a clock like that.
So most of it was casted, and then it was finished by hand.
That engineering is ridiculous. Then, if you think they didn't even have a computer to do it. These days, AI will make you a clock.
I think our biggest problem today is, and we're sitting right in front of it, is time. People don't have time to make this anymore. They want it done as quick as possible.
Do you think this one was made by hand like that?
No, they were definitely still a lot of handmade stuff, but they did have big lathes and stuff for the shafts and stuff. But I think most of the gear finishing and stuff was still done by hand.
Incredible. When you say gear finishing, what do you mean?
They casted rough gears, and then they were finished by hand to get perfect gear teeth.
Yeah. I'm assuming at the end of these, there's also gears down the bottom over somewhere. There must be other gears associated to the bells.
No,
that's just
all running on normal, just swivels and hammers. There's no gearing further down whatsoever. For the past 20 years, I'm absolutely fascinated with clocks. Every day it's something different. And to get these big clocks going again, I mean, like the old church clocks and stuff, it's so satisfying. Really satisfying.